Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest. Check if rectangle corner is reachable. The problem is very interesting and the core solution to this problem is very intuitive. Once you have figured out the core intuition, the rest of the problem can be solved in a lot of different ways. You can either use a DFS or you can use a disjoint set union to figure out one specific part of the problem. So let's get started. The problem states that you're given two positive integers x and y and a 2D array circles where each circle is denoted by xi, yi, ri, where xi and yi is the center of the circle and ri is the radius. Now there's a rectangle in the coordinate plane with its bottom left corner at origin and the top right corner at x, y. Now you need to check whether there is a path from the bottom left corner to the top right corner or not. Now the condition is that path should lie completely inside the rectangle. That path should not touch or lie inside any of the circles that is given to you. And that path should not touch the rectangle itself except at the two corners. So you have to return true if the path exists, otherwise we'll return false. So let's take a few examples. So if you see in this scenario, you can start from here. You can try traversing it in different ways. No matter what you do, you will not be able to reach to this point here. Why? Because there is a barrier that is being formed with this circle which you can't cross at all. And to cross this, you need to go from within this circle, which is not allowed, right? And similarly, you can't come from outside as well because the line should be completely inside the rectangle. So in this case, the answer here is false, right? Now let's talk about this one. In this case, there is a small gap here, right? So you can utilize this and reach to the top right corner. Notice that in this gap, you are not actually touching the corner of the rectangle because you can simply think of it as like you can simply zoom it, and once you zoom you will realize that it is not touching. Like, so basically there is always some possibility at some scale which you can in which you can avoid touching the corners of the rectangle. So here the answer will be true, right? What about this? In this case, again there is a barrier which is being formed with these three circles, and you can't cross this barrier because to cross this barrier you need to go from inside this circle, and hence answer here again will be false, right? Now I would encourage you to pause and try to think what all are the conditions in which you will not be able to reach from the bottom left to the top right cell, right? So there are only 4 conditions. Notice you can't reach the from here to here if there is some sort of barrier which you can't cross at all. Now what all kind of barriers will disallow you from traversing from bottom left to the top right? One kind of barrier is this, which basically means there are some circles which may not lie like completely like this, but that form a line like this. And because it forms a line like this, you can't cross this line without going from inside one of these circles, and hence answer will not be possible, right? Similarly, another possible barrier could be something like this. You can't cross this barrier, and hence you can't go to the other side of the barrier. Similarly, another barrier could be a straight line in the horizontal direction or a straight line in the vertical direction. Now notice that if the circle forms this kind of barrier, let's say this barrier doesn't exist, you don't care because you can simply traverse from the top left to the bottom right very easily through any other path, right? So these are the only 4 barriers that you care about. What does that mean? This means that if you can figure out whether one of these 4 barriers exist in the with the help of these circles, answer will not be possible. That is, you can't reach from bottom left to the top right. If there is no such barrier, like among these 4 there are no such barrier, then no matter what circles are present, where they are present, there is always a path which you can utilize to reach to the top right cell, top right corner. So let's take few example again. In this scenario, you can see there is a barrier with the help of these two circles, or maybe you can use this third circle as well, doesn't matter, but there is a barrier like this which you can't cross, right? So if there is a line which lies completely inside the circle and forms one of the four type of barriers, answer is no, right? Similarly, in this case, you can see there is a barrier like this, so you can't cross this barrier and hence you can't reach to the other side. Similarly, if you can see there, if you start drawing a line that lies completely inside these circles, you will come up with something like this, and you can see this barrier completely separates out this point from this, and hence you can't cross this line and hence you can't reach to the other side. Similarly, another sort of barrier could be like this, and in the same fashion this separates this point from this point fully, right? So what the problem now boils down to is, can I find one of these barriers? If yes, answer is no. If no, answer is yes, right? So how to find these barriers? Again, would encourage you to pause and try to think about yourself. So hope you thought about it. The easiest way is, okay, can I find these groups of circles which are touching in some sense or other together? Like, can I group these together? If I can group these together, I can figure out what's the minimum y and what's the maximum y that these circles have. And once I have this, I can figure out whether these barrier exist or not, right? Similarly, if I know these are the group of circles that are lies together, I can figure out what's their maximum y and what's their maximum x. And if maximum y is greater than y and maximum x is greater than x, I know there is a barrier of this kind. And because there is a barrier of this kind, I can't cross this barrier, and hence answer is false. Similarly, once I group this, I will be able to find what's the minimum x for these circles and what's the maximum x for this circle. If minimum x is less than equals to 0 and maximum x is greater than equals to x, you know there is a barrier, horizontal barrier present, which you can't cross, right? So hope this point is coming sense. So overall, what you need eventually is a way to group all these circles. And if you are able to group this, figuring out the minimum x, minimum y, maximum y is very straightforward. You can simply, let's say you know that C1, C2, C3 all the way up to Cx are in one group. So you can simply go over each of them and figure out their minimum x. Like for each of them, you can figure out the minimum x. How to figure out the minimum x? From center, if you go to the left in the radius direction, that's the minimum possible x that you can have, right? Similarly, for this one, the minimum possible x would be the center minus r, and so on and so forth. For each of them, you know the minimum possible x. You can simply take the minimum across all of them and you will get the minimum possible x across this group. Similarly, for maximum possible x, you will say maximum x for this circle would be center plus radius, right? That's the maximum possible x. Similarly, maximum possible x would be center plus radius. So you will take maximum across all of them and you will be able to figure out what's the maximum possible x. Now notice that these two are not touching, but even then you can take, these and these are not touching, but even then their x, whichever is maximum, you will take that. Why? Because they are touching through some chain, right? So that's why for each, once you figure out each group, you can simply figure out the minimum and maximum x for this group, and in the same fashion you can figure out the minimum and maximum y for that group. Once you have these four information for all the groups, you can easily figure out whether one of these four type of barriers exist or not, and based on whether they exist or not, you will return false, otherwise you will return true, right? Now the only thing that now remains is how to understand or how to group these circles together, right? So there are various possible ways. One way is to use DSU, disjoint set union. You can treat like each of these circle is merely an index, right, in the array. So you can say this is index 0, this is index 1, and so on and so forth. So you can simply check whether which all circle this 0 is intersecting with. So this 0 is intersecting with this one, this 0 might be intersecting with some other circle, right, and so on and so forth. So you can whichever circle this 0 is intersecting with, you can simply merge those two indexes, and you can keep on doing this, and finally you will get a group of disjoint sets. And once you have group of disjoint sets, you can, for each group, you can figure out min x, min y, max x, max y, and figure out one of these 4 barriers. So, and what is the other way? If you don't know about disjoint set, this basically is a graph if you think about it in a very naive fashion. So you can simply say, okay, I have, let's say, 4 circles. Let's talk about this this itself. So we have index 1, index 2, index 3, right? So let's say you took very simple route. You are doing a very brute force manner. You are saying that, okay, I have a node 1, which all nodes this 1 is connected to. So I will try with 2. Is 1 and 2 connected? Answer is yes, because they are intersecting. So you can connect 1 with node 2. Is 1 and 3 connected? Answer is yes, because they are intersecting. So you can connect 1 with node 3. Now you'll go to 2. 2 and 1 is connected, yes. So you will connect 2 and 1. 3 and 2 is connected. Answer is yes. So you will connect 3 and 2. And this will also be connected. Basically, this is a disjoint undirected graph. So once you have found this graph, so let's make it undirected for simplicity. So once you have formed this graph, you can simply do a BFS or DFS or whatever you want to figure out which all nodes are reachable from a node. So you can start a BFS or DFS from 1, figure out what all nodes are reachable, and whatever nodes are reachable, they all belong to a single group, right? In the same fashion, for any other group, let's say there are 2 more circles here, right? And let's say 2 more circles here. So this is 4 and 6, this is 5 and 7. So you can simply connect 4 and 6 as well, and you can connect 5 and 7 as well. So when you start iterating from 1, you will figure out 1, 2 and 3 are reachable from each other. Then you will go to 2. 2 is already visited, so you will not go there. 3 is already visited, that is, it is already a part of one of the groups, you will not regroup it. You will go to 4. From 4, you will see, okay, what all nodes are visible from 4. So 4 and 6 are visible. So 4 and 6 belongs to one group. You will go to 5. 5 and 7 are visible to each other, so they will belong to one group, and that's it. So once you have these 3 groups, you can figure out min x, min y, max x, max y for this, min x, min y, max x, max y for this, min x, min y, max x, max y for this. For this group alone, you will figure out whether min x, min y, max x, max y form one of these 4 barriers. If not, this group is not preventing this corner to be reached from this corner. You will do the same thing for each of the group, and if none of them has a barrier of one of the 4 kinds, you will return true. If any one of have them a barrier, you will return false, right? So let's look at the pseudocode. The pseudocode is exactly what we discussed. We simply iterate over each of the circle, check whether that circle is intersecting with any of the other circle. If they are intersecting, you will simply merge those 2 circles or their indexes, whatever you call it. Now this merge process can be a disjoint set union or can be a DFS or BFS, as we have discussed. Now once you have done this, we will have groups, right? So what we will do, we'll simply go to each circle, figure out which group they belong to, and simply contribute the current contribution to that group. So min x of that group would have one more member to be considered. Similarly, max y, min y for that group would have one more member to be considered, and so on and so forth. So after this entire iteration, I will have min x, min y, max x, max y for each of the groups. So I will now iterate over each of the group. For each group, I will check whether one of the 4 barriers are present. So first barrier is like this. So max y should be greater than equals to y. Max x should be greater than equals to x. So we will simply check if this kind of barrier is present. If it is present, we will simply return false. Second kind of barrier was this. So basically min x should be less than equals to 0. Min y should also be less than equals to 0, right? Sorry, I think this is not correct. So basically this says that the min x should be less than equals to, yeah, I think that's correct. So min x and min y should be both should be less than equals to 0. So it's this kind of barrier. Similarly, to figure out horizontal barrier, you will say whether min y is less than equals to 0 and max y should be greater than equals to y. So min y and max y. And finally, for horizontal barrier, we will have min x and max x. So if one of those 4 barriers are present, you will simply return false, otherwise you will return true. So if for every group you figure out none of the barriers are present, you will simply return true from the function. So that's pretty much it. Now what's the overall time complexity? We are doing for each circle, we are iterating over every other circle to figure out which all circle it connects to. So this loop will take order n square multiplied by, we are doing something to figure out whether the 2 circles are intersecting or not. Now how to figure out whether 2 circles intersect or not? Simple math problem. You can simply figure out the distance between their radius. If the distance between the radius is less than equals to r1 plus r2, it means they are intersecting. If it is greater than equals to r1 plus r2, this means they are not intersecting, right? Simple circle formula. So you can use that simple mathematical formula to figure out whether they're intersecting or not. So this entire intersect function would be order 1. So overall this loop will simply take order n square itself, right? After that, what we are doing some grouping. That grouping can be done with a DFS or BFS or a disjoint set union. Both of them will take order and time overall. After you have grouped, you are contributing min x and min y for each of the group for each of the circle in that respective group. So that will also take order and time. And finally, you are iterating over each of the group. Max, there can be n groups. So overall, this is also order n. So overall complexity is order n square, right? Which will pass because the value of n here is 1000 only. So if you have watched this point, strongly encourage you to pause and try to code this entire thing by yourself. If you are new to DSU, this is a good opportunity to just copy paste DSU from somewhere, get it accepted so that you get more confidence, and then you can learn about DSU further. If you don't know about DSU and don't want to learn it for now, this is also a good opportunity to understand BFS and DFS and write it down as well. Even though you know the code, would still encourage you to write it down so that you can retain this concept for longer. So next we're looking at the code. The code is exactly what we discussed. We iterate over, I've used DSU here. I will show you the code for DSU as well, but we are iterating over each of the pair of circle, figuring out whether they intersect or not. If they intersect, we'll simply merge, right? After that, we figure out the min x, min y, max x, max y for each of the groups. So for each of the circle, we are figuring out the parent or the leader of the group, whatever you call it in DSU, and then we figure out that contribution of that. We just contribute the contribution of that in that particular group, right? After that, we iterated over each of the group. I assume that there are n groups. If there is no, if there are not n groups, some of these will be 1e9 for min and 0 for max. So that will not affect the answer in any condition. So we check one of these 4 barriers. If any of them is present, we'll simply return false. Otherwise, we'll return true, right? Now coming to intersect function, this is very simple. We figure out the distance between the radius, between the center of the circles, and we figure out the sum of radius as well. And if distance is less than equals to radius, distance between the radius, sorry, sum of the radius, you will return true, otherwise you return false. Finally, DSU has simple two functions, parent and merge. Parent is simply if current parent of the current cell is the cell itself, you return that. Otherwise, you will do path compression here. You can avoid path compression as well, that's fine. The merge part will simply check whether they are already merged. If they are already merged, you don't do anything. If they are not merged, you will simply merge the larger one, the smaller one into the larger one, so that the complexity is remain order and login. So hope this entire solution is clear. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.